Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on house robber. This is a classic dynamic programming problem, but let's also see the brute force approach using recursion, and then we will optimize it using dynamic programming approach. So for recursive thinking, let's see the problem first. The problem states that we are given an array where each element represents the money in the house. You cannot rob two adjacent houses, and the goal is to find the maximum money you can rob. So for example, if you rob this, the total amount would be 1, and you cannot rob the second house because it is adjacent to 1. So you will rob the third one, which has the money 3. So 1 plus 3 would be 4, and 4 is our answer. If you consider this, 2 plus 9, 11 plus 1, 12. You can also rob 7 plus 3, but that leads to robbing only 10. But 12 is maximum. We need to find the maximum. We need to rob the maximum money that we can do. So the key idea is at every house you'll have either two choices. Either you rob the house or skip the next house. Either you rob the current house and skip the next house, or skip the current house. So let's write the code for that. Um, let's call a helper method passing nums and index 0, because we need to know at which index we are robbing. So the return type for this would be int, because we need the total amount robbed. And let's implement the method helper. This is nums and this is index. Now we need to check if this index is greater than or equals to uh, the length of the given array. That means that we have completed the array. We have completed robbing all the houses that are possible. So let's check if index is greater than or equals to nums dot length. If it is, then we will return 0, because we don't have anything left to rob. Now we have two choices. Either we rob the current house or we skip the current house. So in case if you rob the current house, then let's take a variable rob, and if you rob, then it would become nums of index plus, and then we will call the helper method by passing the input array nums. And now that we have robbed index, now that we have robbed the house at index, we cannot rob the house at index plus 1, because we cannot rob the adjacent house. So we need to rob index plus 2. So we need to pass nums and index plus 2 to the helper method now. In case if you skip it, then we are not adding this because we skipped it. Instead, we are calling the helper method directly. But since we skipped the current house, we can call index plus 1, because the current house is skipped. Index plus 1. Okay, now at the end we will return whatever is the maximum between these two. That is it. Let's run the code. It is accepted. So here we are solving the same sub problems again and again, because I'll show you by dry running. So the time complexity here becomes 2 power n because we are using recursion approach, and at every step we have two options: either we rob the house or either we rob the house or skip the house. So at every step, since we have two options, the time complexity would be O of 2 power n, and this will lead to TLE for larger inputs. So this overlapping sub problem behavior tells us one thing, that we need dynamic programming. So dynamic programming is nothing but we will be saving whatever is already calculated instead of recalculating it again and again. So let's see the code for that. Okay. Okay, this is the actual method given. Now let's take a variable n with the length of the given input array, and here the edge cases are: if n is 0, then if n, which means the length of the given array, is 0, then we will return 0 because there are no houses to rob. And if n is 1, then we will return that house itself because there is no adjacent house to skip or rob, and that is the only house available. So the robber will straight away rob that house. Now let's take a DP array, p equals to new of size n. Okay, now DP, let's make DP of 0 as nums of 0, and DP of 1 would be, these are just the initial values. Okay, DP of 1 would be math.max nums of 0 comma nums of 1. Now DP of 0 index is calculated, first index is also calculated. Now let's calculate the values from index 2 till the end of the array. So how do you calculate that? We will simply calculate DP of current index I as the maximum of DP of I minus 1 comma the current value nums of I plus DP of I minus 2. This formula is nothing but the one which we have written here. For robbing, we are taking the current value and summing it up with the values that we get from this helper method, passing index plus 2. Since this is recursion, we are coming from backward. So yeah, and so this means this DP of I minus 1 is for skipping, and this nums of I plus DP of I minus 2 is for robbing. Now after calculating this, at the end we will simply return the answer where we will have it in the last index n minus 1. Let's run the code. It is accepted. Let's submit it. It is accepted. So okay, for example, if you consider this, at index 0, the current element is 2, so the DP of I in the DP array is updated with 2, because here we are assigning DP of 0 with the first element in this, and the second element DP of 1 would be the maximum of nums of 0 and nums of 1. So the maximum of 2 and 7 is 7. So we updated it with that. And at index 2, the current value is 9. So we are checking the maximum of 7, the maximum of the previous element 7 and current element 9 plus 2, the previous to previous element. So the output would be 11. So that is nothing but the current element 9 plus previous to previous element 2 is 11. At index 3, the value is also 3. So the maximum would be the maximum of this 11 and 3 plus previous to previous element 7. So which is 11. Now at index 4, the current element to rob, the money that he can rob is 1. So the maximum of this 11 and this 11 plus 1 would be 12. So the answer is 12. So yeah, the time complexity is O of 1 because we are doing it in a single pass, and the space complexity would also be O of 1 because we are using an extra DP array. So this space complexity can also be optimized, but I'll be discussing in coming videos. So that is it for today's problem, and I will see you in the next one.